Good afternoon, dear students. Welcome to St. Patrick's College Oka e-learning platform. I hope you are having a great moment in this short break. Well, I wish to use this opportunity to have interaction with you in continuation of our topic on algebraic expression. I still remain your mathematics teacher, Mr. Ndubisi Ephraim. I believe some class may have done some part of this lesson, but for those who are yet to, I hope you can take this serious, so that by the time we come back, we will still look at the same topic once again, revise it, and also to accommodate those who may not have the opportunity to enjoy this lesson at this moment. So let's get started. Let's begin by identifying the specific objectives of this lesson. These are some of the things you are expected to comprehend towards the end of the lesson. So by the end of the lesson, you ask yourself questions whether you have been able to comprehend some of these outlines. The first, you should be able to define algebra and give examples of algebraic terms. 2. You should be able to simplify by collecting the like and unlike terms of algebraic expression. 3. You should be able to open the brackets involving algebraic terms. 4. You should be able to solve to find the solutions of simple equations, but the simple equations and the ones involving fractions. We are going to see all of them. Now let's begin with the first objective: definition of algebra and examples of algebraic terms. Algebra is the branch of mathematics that deals with use of numbers and letters together. So they involve the use of numbers and letters, like we have in the examples of algebraic terms below. Examples of algebraic terms are: we have 2x, 3y, 7x over 8, and so on. These are what we call the algebraic terms. As you can see from our definition, each of these terms are made up of number and letter put together. Likewise, this one, it must not be only x and y, it could be any other letters, m, n, z, and so on. Alright, so we have some problems here to simplify regarding like terms of algebraic expression. Now, looking at the first question here, we have 6y plus 3y. Number 2, 6h minus 10h. Number 3 is 4k plus 10k plus 6k. Number 4, 22x minus 13x plus 2x minus 5x plus 7x. When you look at each of these questions, you'll find out that they share similar letters. And when they share similar letters, you call them like terms because they look alike. They have something in common. And for number 1, what do they have in common? Y. We have 6y plus 3y. You can see both of them are wearing the same shirt. This one is wearing shirt Y, that's a 6y. 6 is wearing shirt Y, and 3 is also wearing shirt Y. So they have the same alphabet. For that reason, we call them like terms. And once they are like terms, we can always add them together. But if they are not like terms, like we'll be seeing in our solutions going forward, they cannot be added together if they are not like terms. Now, let's begin with the solutions of these various questions. Question number 1. Here we have 6y plus 3y. Just like I said, they have the same alphabet. For that reason, they are called like terms. So we can evaluate them together in terms of addition or subtraction. Alright, so looking at it here, we have 6y plus 3y. I add both of them in bracket because they share y in common. But you can equally do it from here by saying 6y plus 3y, which will give us 9y. Or you put it in bracket like I did it here. That will be 6 plus 3, which will give us 9. and both of them are having y in common. So 6y plus 3y will give us 9y. Then number 2, we have 6h minus 10h. And the answer to this question will be minus 4h. I know some of you may be wondering, why is there minus in the answer to this question? Now let's take a look at two different expressions here. If I have 10 minus 6, what will actually be your answer? The answer will be positive 4. Why? Because big number minus smaller number will always give you a positive answer. Alright, so for the question we have here, we have a smaller number subtracting a bigger number. Therefore, you are going to have a negative of the answer. Just like we described in the class, as you have 6 minus 10, that will give us negative of the answer. That will be minus 4. Just like I described in the class, you take plus as what you have in your pocket, the money you have in your pocket, minus as what you are owing somebody, the amount you are owing somebody, or you borrowed from someone. Let's use that ideology to answer the first question. Here you have 10 is equally the same as plus 10. So that is to say you have 10 in your pocket, then minus 6, meaning that you are owing 6 naira. So if you have 10 plus 10 in your pocket and you are owing 6 naira, that's minus 6. When you pay what you are owing, remember you have 10 naira in your pocket, but you are owing 6 naira. When you pay this amount you are owing, you have 4 naira remaining in your pocket. You have balance of 4 naira. And in this case, you are not owing again. So it is a positive number that you are going to have. Then, in this case, we have plus 6. Remember, if you have it as plus or just 6, they are of the same thing, because that addition sign is invisible. So plus 6, what you have in your pocket now this time around is 6 naira. Then minus 10, what you are owing is 10 naira. So, as you have 6 naira in your pocket, you are owing 10 naira. When you pay the person you are owing 10 naira, 6 naira, have you paid complete? Absolutely no. You will still be owing. How much will you still be owing? 4 naira. That means minus 4. So you can always use this ideology to answer such questions as it has to do with addition and subtraction to avoid mistakes. So for the question we have here, 6h minus 10h will give us what? Minus 4h. I hope it's quite clear. Then number 3, we have 4k plus 10k minus 6k. Just like we did in the previous ones, we have 4 plus 10, which will give us 14. Then 14 minus 6, which will give us what? 8. That's 8k. Alright, so number 4, 22x minus 13x plus 2x minus 5x plus 7x. 22 minus 13 will give us 9. 9 plus 2 will give us 11. 11 minus 5 will give us 6. Then 6 plus 7 will give us 13. That will be 13 what? X, because they all share x as a similar term. Alright, so we move to the next outline. That is multiplication and division of algebraic terms. Multiplication and division of algebraic terms. This time around we'll be dealing with multiplication and division. Previously we were dealing with signs such as plus and minus, but this time around we'll be taking a look at the algebraic terms in terms of multiplication and division. Now we have 3 times 4x here as the first question, and number 2 we have 4x times 3y. Number 3 we have y times y times y times y. Then number 4 we have 6x squared y squared divided by 2y. Number 5 we have 6ab all over 5 divided by 8ac all over 15. Now let's look at the solution to these questions. Solution number 1, 3 times 4x. Recall when we were doing addition, you were told that when they are on like terms, in terms of addition, they can never come together. In terms of subtraction, they can never be evaluated together. But whenever you are dealing with multiplication of algebraic terms, whether like terms or unlike terms, they can always come together in terms of multiplication or division. Like we have in the question here. Remember, if we have the question as 3 plus 4x, the question will be, can we evaluate them together? Can we evaluate them together? Can we bring them together? The answer is no. The reason being that both of them are not like terms. This one is having x, whereas this one is a constant value, not having any alphabet attached to it. So they are unlike terms. In terms of this addition or subtraction, you can never bring them together because they are unlike terms. But in terms of multiplication, we can always bring them together, or in terms of division, if it can actually be divided. But in terms of multiplication, we can bring them together. So we have it as 3 times 4x. That will be 3 times 4x will give us 12x. That is 3 times 4. X is attached to it. That will give us what? 12x. I hope it's quite clear, so that you don't make mistake between when you are using minus or plus or multiplication. Alright, so let's move to the next one. Number 2, we have 4x times 3y. 4x times 3y. 4 times 3 will give us 12. X times y will give us xy. So therefore, 4x times 3y will give us 12xy. Then number 3, we have y times y times y times y. Y times y times y times y. That will give us y raised to power 4. The reason being that we are dealing with index. Now, if you have the question, because this used to confuse some students, especially when you are having something like this. Let's say y plus y, or when you are having y times y. How do you approach this? What is the difference between the two of them? When you have y plus y, you are actually adding them as a whole. That is y plus y. That will give us 2y. But when you have it as y times y, that becomes a product. It becomes a product, and in this case you write it in index form. So therefore the answer will always be power when it has to do with multiplication of the same alphabet. So as we have y times y, the answer will be y raised to power 2 as your answer. So that's the difference between the two of them, because sometimes some students will write this as 4y, but that's not the case. So when you are dealing with multiplication, you multiply all of them, it will present its answer in index form when it has to do with multiplication. But if it's addition, it's going to be in the whole of how many y's do I have here? Y plus y plus y plus y. That will be what? 4y, as the case may be. But in this case, in terms of multiplication, it has to be a power. Then number 4, we have 6x squared y squared divided by 2y. I represent this in this form, representing this sign of division with this line of division here. They are the same thing. So what I have will now be 6x squared y squared, which is what I have here at the numerator, divided by, which means the same thing as this line, 2y. So from here, what we need to do is to reduce these terms in their lowest terms. So let's reduce them to their lowest terms. That is to say, y dividing y raised to power 2. That will give us y as our answer here. Then 2 can equally divide 6. So 2 divide itself will give us 1. And 2 divide 6 will give us 3. When you look at the numbers you have above and below, nothing can divide again. In fact, the numerator has been divided completely. Nothing remains there except 1. And you know that anything divided by 1 will still give you the same number. So what do we have left here? That will be 3x squared y, which we can say 3 times x squared will give us 3x squared. 3x squared times y will give us 3x squared y, and that becomes the answer to the question. Then number 5, we have 6ab over 5 divided by 8ac over 15. This looks quite like division of fraction, because what we have here is fraction, even though we are dealing with algebraic fraction, because it's an algebraic term arranged in a fractional form. So it's still the same process that we have to follow, division of fraction. So that means we must change this sign of division to multiplication. And when we do that, the fraction in front of the division sign will switch positions, meaning that this 15 will take the place of 8ac, and 8ac will come down to take the place of what? 15. That is to say, both of them will switch position. It is only done when you are dealing with division of fraction, and most importantly, when you are changing this division sign to multiplication sign. So we now have it as 6ab over 5, which we have here, times, that is changing this division to multiplication, meaning that 15 will now go up, 8ac will now come down, just like we have it here. When that is done, the next thing we have to do is to reduce this expression to the lowest term. Now, when you look at the numbers we have at the numerator and the ones we have at the denominator, we look at for numbers that can actually reduce between the one that we have on top and the one we have below. And when you look at it closely, 5 can divide 15, because 5 times 3 will give us 15. So therefore, 5 divide itself will give us 1. And 5 divide 15 will give us 3. That will give us 3. Then let's look out for another thing that can actually divide. We have a here, we have a here, so they can cancel out. So a cancel out a. Then is there any other thing that can cancel? Now look at 6 and 8. Can anything reduce both of them? Yes. And what is that number? That is 2. So 2 can divide 6 and can equally divide 8. So 2 divides 6 will give us 3. That will give us 3. Then 2 divide 8 will give us 4. Now let's look at the numbers we have once again. Is there any number between the numerator and denominator that can actually divide again? When you look at it closely, nothing can divide between the numerator and denominator again. So what do we need to do? We times through. We multiply the remaining ones. That is between the ones that are above and the ones that are below. Then above, which is the numerators, we have 3b and 3 left. So we can now put them in terms of product because we are multiplying between them. 3 times 3 will give us 9. Then 9 times b will give us 9b, as we have it here. Then the remaining one here, 1 times 4 will give us 4. Then 4 times c will give us 4c. So that will be the solution to this question. Alright, so we can now move to the next slide for other ones. Here we have a simplification of algebraic expression, continuation of the lesson, collection of like terms. This time around, we will not be dealing with like terms alone. We'll be having mixture of different kind of terms, and all we need to do, all we are required to do, is to bring together those ones that look alike. That is what we mean by collection of like terms. And when we do that, we simplify at the same time. So we have some problems here to solve. The question says collect the like terms in the following and simplify. Number 1, we have 2x plus m minus 4 plus 5x minus 6m. Number 2, we have 3a minus 4b minus 2a minus b. Let's start with the first one. As you can see, each of these terms has a sign before it. For this particular one, students, what sign stands before 2x here? And that will be plus. Whenever you have a number without any sign in front of it, plus seems to be the number, the sign that is in front of such numbers. And we used to say that they are invisible, they are positive numbers. So for m, we have plus m here. Then for the next one, we have plus 4. So to every term, there is always a sign before it. Then for this next one, we have it as plus 5x. Then the last but not the least, minus 6m. So whenever you are collecting like terms, make sure as you move this number closer to their like terms, make sure you move the numbers along with their signs. Don't make mistake of leaving out the signs. Alright, so because some students make mistakes when it comes to moving some of these terms. Alright, so let's take a look at the answer, the solution to this. The first one we have here is 2x, which is exactly what we have here. Do we have anything that has to do with x here? Yes, and that is what? Plus 5x. Not just 5x, but what? Plus 5x. So we carry plus 5x, bring it closer to his brother 2x. So you can see they are very close to each other now. We have collected the two like terms. They are closer to each other. Then we are done with those ones that has to do with x. So let's proceed to the next alphabet, which is m. Is it m? No, it's not just m, but what? Plus m. So that's exactly what we have here. Does m has a brother here? Yes, that is what? Minus 6m. Not just 6m, but what? Minus 6m. So we get it closer to his brother m. Alright, so we are done with the letter, the one that has to do with m here. Which other thing do we have here? And that is minus 4. So we write it last. It doesn't have a brother. That is the one that has no alphabet attached to it. Now, let's begin to bring them together. That's what we mean by simplification. Let's bring them together in terms of their like terms. Those ones that are like terms, bring them together. Now we have 2x and we have 5x. And we have plus between them. So 2x plus 5x will give us 7x. We are done with the family of x. Now let's move to the next one. That is plus m minus 6m. Plus m minus 6m. We can actually write it as m minus 6m. Okay, somebody may begin to ask a question, where is our plus in m? Are they not the same thing? They are the same thing because both of them are positive terms here. Alright, so whether you put the plus here or not, they mean the same thing. But if it is minus that is here, don't assume it to be the same as m. Okay, so you can actually leave it as plus what? M. So what we have here is 1m minus 6m. What will it give us? Can you recall? If we have 1m, just let's take it as 1 minus 6. 1 minus 6. You can see small number minusing a big number. Can you still remember what we did previously? Or you take 1, that's the plus 1. You have 1 naira, but you're owing 6 naira. When you pay, you will still be owing 5 naira. That means minus 5. But in other words, when a small number is minusing a big number, it will give you a negative of the answer. So 1 minus 6, that will give us minus 5. So that's why we have it here as m minus 6m will give us minus 5m, then minus 4. Can we bring them together further? No, we cannot do that. Can you tell me the reason? Somebody may have gotten the answers. Yeah, the reason being that they are unlike terms. They are not like terms, so we cannot bring them together again. Alright, so that's the answer to that first one. Similarly, that's exactly what you do in the second one. We have 3a here. Then where is the brother? Minus 2a. So we bring it closer. We are done with a. So we move to b. Minus 4b. That's exactly what we have here. And the brother is what? Minus b. So 3a minus 2a will give us 1a. Then here we have minus 4b minus b. It's not just 4b minus b, but what? Minus 4b. Remember to always apply the sign before any term whenever you are evaluating or simplifying any algebraic term, because making mistake with the sign, you will get it wrong along the way. All right, so let's get this done. We have minus 4. Let's take it as a number, ordinary number. Let's forget about the m for now. Minus 1b. That's minus 4b minus 1b. Remember our concept of owing. All right, so minus 4, you are owing 4 naira. Minus 1, you are owing 1 naira. How much are you owing altogether? This time around, you have nothing, because had even there is plus here, we would have said yes, you have some money in your bank account or maybe in your pocket, probably. So you have minus 4, you are owing 4 naira. Minus 1, you are owing 1 naira. How much are you owing altogether, Mr. Man? You are owing 5 naira. What do we write it to be? Minus 5. So here we have 3a minus 2a, we give us a. Then minus 4b minus b, we give us minus 5b. And that is the solution to this particular one. Let's quickly move to the next outline. That is use of brackets. Before we go into solving these problems, let's have a look at these important things here. I believe you can still recall what we did in the class. We've done something similar to this before. So let's look at this. You must carry this in your mind. It is very, very important in mathematics. Plus times plus will give us plus. One thing that will always make you to remember this is that whenever the same sign multiply itself, they will always produce positive. That is plus. That is why we have it here. Plus times plus will give us plus. Then the same sign again, minus times minus, we still produce what? Plus. Then when they are of different sign, they will always produce what? Minus. That's in terms of multiplication. Then plus times minus will give us minus. Then minus times plus will equally give us what? Minus. This is very, very important going forward. Now let's begin to apply it in solving these brackets. Here we have some problems from number 1 to number 6. Now let's look at the solution to these questions. Solution number 1. Here is the question: 3 plus bracket x plus 2. What we do is that whatever we have outside attached to the bracket, we open the bracket. That means what we have attached to the bracket here is plus. So this plus will multiply each of the terms we have inside the bracket. So we now take it this way. So plus, we multiply everything here. We bring down our 3. Then plus times x will give us what? Plus x. Plus times plus 2. Remember, plus times plus is plus. Remember. So plus times plus 2 will give us what? Plus 2. Okay, so we can now simplify further by collecting like terms. When you look at this, it's only this particular one that has x. But this one and this one has no alphabet attached with it. So therefore, both of them are like terms. So we have it as 3 here. Then plus 2 coming closer here, that's a collection of like terms now, plus x. Then 3 plus 2 will give us 5. Then plus what? X. Can we bring them further together? Do we write it as 5x as our answer? Absolutely no. We cannot do that. And you know the reason? The reason being that they are unlike terms. We cannot bring them together in terms of addition or subtraction. Remember that. Alright, so let's move to the next question. Number 2. We have 3 minus bracket x plus 2. Bracket close. Now, similarly, we can now bring down our 3 using our minus, which is attached to the bracket, to multiply everything we have inside the bracket. Alright, so let's take a look at it now. We have 3. Minus times x will give us minus x. Minus times plus 2. Remember that minus times plus is minus, right? So minus times plus 2 will give us minus 2. Okay, I hope it's very clear. Now we can further collect like terms just like we have done previously. This one and this one, they are like terms. So we have 3, then minus 2 minus what? X. So 3 minus 2 will give us 1, then minus x. We cannot bring them further together because they are unlike terms. Then number 3, we do the same thing. 3, we bring it down, then minus times x will give us what? Minus x. Then minus times minus 2 will give us plus 2. Do you know why? Because minus times minus is plus. Alright, so minus times minus 2 will give us plus 2. Then collecting like terms, 3, then plus 2 minus x. Then 3 plus 2 will give us 5. Then minus x. So we can bring it further. And those are the solutions to the question. Then number 4. Question number 4. Here we have 5 bracket 2a plus b. This time around 5 is attached to the bracket, so 5 we multiply everything we have inside the bracket. That is to say 5 times 2a, after which 5 will equally times plus b. So let's take a look at it now. 5 times 2a will give us 10a, plus 5 times plus b will give us plus 5b. So that's the answer to the question. We can't go further than this because you cannot add them together because they are unlike terms. This one is 10a, whereas this one is 5b. So they are of the same family. This one is Mr. 10a and this one is Mr. 5b. They can never live in the same house because they are not of the same family. Alright, so we move to number 5. We do the same thing, opening our bracket. For this first bracket, 4 is attached to the bracket. So 4 we open the bracket by multiplying everything we have inside the bracket. Then likewise, the second bracket, what is attached to the bracket is not just 2 but what? Minus 2 is attached to the bracket. So we use it to multiply out everything we have inside the bracket. So let's begin with the first one. 4 times a will give us 4a. 4 times plus b will give us plus 4b. Then we move to the second bracket. Minus 2 times 2a will give us minus 4a, because 2 times 2 is 4. I hope you know that. Then minus 2 times 2a will give us minus 4a. Then minus 2 times plus 3b, minus 2 times plus 3b. Remember that minus times plus is minus, right? So when I say 2 times 3b will give us 6b, because 2 times 3 is 6 and 3 is attached with what? B. So therefore we can say minus 2 times plus 3b will give us minus 6b. The reason being that minus times plus is minus. You can see, remember. Now we collect like terms. We have a. Does a have a brother again? Yes, that's minus 4a. So bring it closer to his brother. Then we are done with a. We go to b. Plus 4b. That's what we have here. Then plus 4b, where is the brother? That is minus 6b. So we have minus 6b here. So we can bring them together in terms of their likeness. Alright, so 4a minus 4a will actually give us what? 0. So it's nothing here. Then 4b, we're having it as plus 4b. Or you say 4b minus 6b. Can you still remember when a small number is minusing a big number? It will always produce a negative of the answer. So 4b minus 6b will give us what? Minus 2b. And that is the answer to that. Because if we have 0 here, I know some of you may write 0 minus 2b, and that 0 will have no effect. Because 0 minus 2b will still give us what? Minus 2b. And that is the answer to that particular one. Then number 6. What we have attached to the bracket is minus 4. So minus 4, we open the brackets. So minus 4 will times 5x, and minus 4 will equally times plus 6x. So minus 4 times 5x will give us minus 20x. Minus 4 times plus 6y. Remember that minus times plus will give us minus, right? So minus 4 times plus 6y will give us minus 24y. And that is the solution to that particular one. And we cannot go further than that. Do you know the reason? Who can tell me the reason? Yeah, somebody may have gotten the answer. The reason being that they are unlike terms. So we can never bring them together once they are unlike terms. Alright, so let's move to the next outline. Let's move to the next outline. Solution of simple equations. Solution of simple equations. Some of you may begin to wonder, why are we not calling it equation this time around? Whereas at the other end, we were calling it expression, algebraic expression. This time around, we are talking about algebraic equation. If you check the previous ones we have solved, you'll find out that the things we have here, we have no equal sign in our solving here. So in such, we call it expression. But when you have equal sign as in the case of this one, x minus 7 equal to 15. So that's when you call it equation, because it's been equated from the word equal. All right, so that is the difference between expression and equation. Without this equation, equal sign here, this is just an expression, so it's an equation now. So solving simple equation, just like the name implies, it is quite simple. All right, so let's look at the solution to these questions. Let's look at the solution to the questions. Number one, we have x minus 7 equal to 15. X minus 7 equal to 15, and we are solving for x because this is an equation. How do we go about that? Our interest here is to make sure that this x stands alone and every other number goes to one side, so that x can stand alone. X is pushing every other number towards the right hand side so that it can stand alone. Okay, so for us to solve this, what we do mathematically is that for us to eliminate this minus 7 to do away with x, all we need to do is to add 7 to both sides. When you have minus, you add to both sides. So when we add 7 to both sides, you find out that this 7 will cancel out, because when we now have minus 7 plus 7, what will it give us? That will give us 0, because just like what we explained previously, minus 7 meaning that you are owing 7 naira, plus 7 meaning that you have 7 naira. So if you have 7 naira in your pocket but you are owing 7 naira, when you pay what you are owing, you have nothing left, so that will make it to be what? 0. Or in other words, like we normally say, we take this minus 7 to the right hand side, and minus 7, when it comes to the right hand side, it becomes what? Plus 7, just like we have it here. The sign will change. When it crosses the equal sign, the sign will change. But remember, not in the case of an expression, because an expression you don't have an equal sign, so the sign will not change. Alright, so for this particular one now, we take 7 to the right hand side, minus 7 to the right hand side, and when you do that, it turns to become what? Plus 7. So you now have it as s is equal to 15. Then minus 7 going to the other side become what? Plus 7. So you now have it as x is equal to 15 plus 7 will give us what? 22 as our answer. Then number 2, we are still going to do the same thing. We collect like terms. Collecting like terms meaning that this minus 10 we have to move to the other side where they have a similar term. Alright, so and it is minus 10 here. Remember, when it goes to the other side, become what? Plus 10, just like we have it here. So we now have it as 13x is equal to 29. Then minus 10 moving to the other side will become plus what? 10. Remember, mathematically we call it adding 10 to both sides. That will eliminate that 10 from x. Alright, so when we take it to the other side, become plus 10. So here we have 13x is equal to 29 plus 10 will give us 39. So what do we do next? We divide both sides by the coefficient of x. Recall, we have done coefficients of terms. So the coefficient of x here is what? 13. So whenever you get to this stage, what you do is that you divide both sides. What do we mean by both sides? The left and the right hand side. You divide both by the coefficients of x, and the coefficient of x here is 13. So we use 13 to divide each of them. So we use 13 to divide this side. Then we equally use 13 to divide this side. We use 13 to divide this side. Sorry, my handwriting here is not quite good. Alright, so in this case 13, we cancel 13. We are left with x as we have it here, equal to 39 divided by 13, just like we have it here. So we know that 13 times 3 will give us 39. Therefore 39 divided by 13, the answer will be what? 3. Then number 3, we have 7t minus 2 is equal to 5t plus 10. We are going to be collecting like terms, meaning that we'll be bringing 5t coming back home to meet his brother, senior brother, 7t. You can see 7t is already here, so this one is plus 5t coming home to meet his brother. He will become minus 5t, just like we have it here. Alright, then this minus 2 will equally move to the other side to meet his elder brother 10, and it is minus 2 here. When it comes to this side, become what? Plus 2. So we now have it as 7x minus 5x is equal to 10 plus 2. So 7x minus 5x will give us 2x. Then 10 plus 2 will give us 12. So what do we do next? We divide both sides by the coefficients of x. And the coefficients of x here is what? 2. So we divide both sides by the coefficients of x, which is 2. And when we do that, x we cancel 2 will cancel 2 rather. Then we have x left here. Then we now have 12 divided by 2, just like we have it here. And 12 divided by 2 will give us 6 as our solution. Then finally, number 4. Here we have 2 bracket 2x minus 4 bracket close is equal to 12. How do we approach this one? The first thing we have to do is to open the brackets. And opening the bracket means that this 2 that is attached to the bracket, we open everything, multiply everything inside the bracket. Alright, so just like we did previously, so 2 times 2x will give us 4x. 2 times minus 4 will give us minus 8 is equal to 12. Then we collect like terms. So that means this minus 8 we move to the other side to become plus 8. So we have it as 4x is equal to 12. Then minus 8 coming to this side become what? Plus 8. Then we now have it as 4x is equal to 12 plus 8, which will give us what? 20. What do we do next? We divide both sides by the coefficients of x, and which is what? 4. And when you divide both sides by 4, this particular one will cancel out. When we divide by 4, that will now be 4 cancelling out 4, as we have it here. We are left with x, as we have it then 20 divided by 4, which will have it then x is equal to 5 as our solution. So that's how to go about this. Then the next one, next outline we have is simple equations involving fractions. This will be the final outline we have for today's lesson. This time around we are dealing with simple equation involving fraction. Remember, we call it equation because it has equal sign here, and we call it involving fraction because we are dealing with numerator and denominator. And whenever you have numerator and denominator expressed as a number, you call it what? A fraction. Alright, so we are going to be solving this algebraic fraction. So let's move to the solution of these questions. Solution number 1. This one is quite easy. All we need to do, whenever you have a term at the left hand side, then another term at the right hand side, that having one term at the left, one term at the right, you can do cross multiplication in solving this. You can use cross multiplication. What do we mean by that? That means the one you have up here multiply the one you have down at the other side. Then 3 you have here, we cross multiply 4 at the other end. So how do we do that? As we cross it, we multiply. That's what we mean by cross multiply. So let's start with the one with an alphabet. 5y times 2 will give us 10y equal to, we move to the other cross, that is 4 times 3, that will give us 12. That's quite easy. So what we need to do now is to divide both sides by the coefficients of y, and the coefficient of y is 10. So we divide both by 10, and when we divide both by 10, that can cancel out at the left, and we use it to divide the one at the other end. And when we do that, 10 we cancel out 10 here, then we are left with y as we have it here, then equal to, then we have 12 over 10 as we have it here. Then we cannot go further to reduce to the lowest 10 because 10 cannot divide 12 exactly. So what number can divide both of them? And that is 2. 2 divide 12 will give us 6. 2 divide 10 will give us 5. So therefore we have it as 6 over 5, which when we change to mixed fraction, we have one whole number, 1 over 5. And that is the answer to this question. Alright, so number 2. Similarly, remember the question happens to be like this. There wasn't over 1 there, so I was the one that attached over 1. So you have it as a whole number here. You can actually express it as a fraction so that you won't make mistake in solving that particular question. So let's move to the solution again. To number 2, we have 3x over 4 is equal to 9 over 1. So we do cross multiplication once again in solving this. So 3x times 1 will give us 3x. 4 times 9 will give us 36. So we divide both sides by the coefficients of x, which is what? 3. And when we divide both sides by 3, that will present us with an interesting answer. Then 3 we cancel 3 as we have it here. Then we are left with x is equal to 36 over 3. So 36 divided by 3 will give us 12. And that is the solution to this particular question. 12 is the answer. Alright, so let's move to the other solution, which is the last question we have for today. Alright, so for this particular one, we have more than 2 terms. Unlike the other one, we have a particular term at the left, we have another term at the right. So in that case, we cross multiply. But this time around, we have more than 2 terms here. So cross multiplication cannot work in this form. So the first thing you do whenever you have this kind of a thing is to find the LCM of the denominators. And the LCM of this denominator, 5 and 3, is 15. So the next step will now be you multiply each of these terms. Look at the terms here. You multiply each of them by that's your LCM, which is what? 15. So for this particular one, that's 3m over 5. You times it by your LCM, which is 15. Then minus, as we have it here, m over 3 minus m over 3. We times it by our LCM, which is 15 over 1. So each of them you multiply by that your LCM, which is 15. Then equal to the last one, which is what? 8 over 5. You times it by your LCM. Alright, so we can now clear the numbers we have below. 5 can divide 15. So 5 divide itself will give us 1. Then 5 divide 15 will give us 3. That will give us 3. Then we move to the other one. 3 divide itself will give us 1. Then 3 divide 15 will give us 5. Then we move to the next one. 5 divide itself once again will give us 1. Then 5 divide 15 will equally give us 3. Alright, so we can see that we have cleared the denominators. So we multiply the ones we have at the numerator left. So 3m times 3 will give us 9m. Then minus m times 5 will give us 5m equal to, then 8 times 3 will give us 24. Wow, you can see how we were able to clear the fraction. It's now looking pretty solvable. Now the next line we do is the like term has already been collected because we have 9m minus 5m here, so we don't need to take any number to and fro, or maybe moving it from one side to another, because the like term has already been collected. So 9m minus 5m will give us 4m is equal to 24. So we divide both sides by the coefficients of m, which is what? 4. We divide by 4, divide both sides by 4. And when we do that 4, we cancel out 4. Then we are left with m. Then 24 divided by 4. Remember that 4 times 6 will give us 24. So therefore 24 divided by 4 will give us 6. So you can see that this question is quite easy. It's just for you to follow the right steps in solving it. That will make you to be able to understand it quite well. So this will be the end of our lesson for today. I hope it's quite interesting. I really thank you for listening, and I hope to see you when we return from our midterm break. So here are the assignments you have to do. Do this assignment in your notebook, so that by the time you come back, we'll be able to mark it and assess ourselves. But remember, we will still do revision to this particular topic that we have discussed already, so that we'll be able to carry everyone along. So I wish you a wonderful week ahead and have a blessed day. Bye. Bye bye.